Hi students. Hi students. In this class, we are going to discuss about exponents and powers. Exponents and powers. So first of all, what is the exponent? Exponents is nothing but it is the representation of a number. Representation of a number. So suppose let me consider if a number is multiplied repeatedly. If a number is multiplied repeatedly, suppose 2, I am going to consider 2 into 2 into 2 into 2 into 2. Suppose when I am going to multiply 2 one first time, second time, third time, fourth time, fifth time, that means 5 times. So when I am going to multiply 2 in 5 times, so this can be represented in the form of 2 is multiplied by 5 times. 2 is multiplied by 5 times. This can be written as 2 to the power of 5. 2 to the power of 5. So this can be written as, this can be read as 2 to the power of 5, or 2 is raised to the power of 5. 2 is raised to the power of 5. This is called 2 to the power of 5. So what is the value? 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So now 32 can be written as 2 power 5. That means 32 can be represented in the form of 2 power 5. That means any number can be represented if it is exponential. Now this number can be splitting into its equal factors. That is equal factors. Any number can be represented in the form of equal factorization. That is 2 into 2 into 2 into 2. So now in the same way 3 into 3 into 3 into 3. Now 3 is repeatedly multiplied 4 times. Then this can be written as 3 power 4. If any number is repeatedly multiplication, that expression is nothing but exponential form. So in this case, the number which is repeatedly multiplied, which number is repeatedly multiplied here? 3 is repeatedly multiplied here. 3 is repeatedly multiplied. Hence, the 3 is known as base. 3 is known as base. A number which is repeatedly multiplied is nothing but base. So the number, how many times it is repeated? Number of times repeatedly multiplication. Number of times is nothing but exponent. Exponent or power or index also. Index. Okay, indices. Okay, we are calling this as, so 3 power 4, 3 to the power of 4, or 3 is raised to the power of 4 is known as, so this value is 81. 3 3s are 9, 9 3s are 27, 27 3s are 81. This 81 can be written as 3 to the power of 4. That means 81 can be represented in the form of 3 to the power of 4. If any number can be represented in the form of its powers, then it is known as exponential form. Exponential form. Suppose if A is a number, let me consider A is a number. So let A is repeatedly multiplied, A into A into A into A into A and so on. This is m times. So simply we are going to represent. Already we know that. So which number is repeated here? A. That means A we should consider as base. How many times? Simply they are given m times. That is power m. So this can be represented as A to the power of m. A to the power of m, or A is raised to the power of m. This is known as exponential form. Exponential form. Now, apart from this, nothing is there. Here, suppose minus 4 is multiplied 3 times. This can be written as minus 4 power 3. If any number which is repeatedly multiplied, it can be represented in the form of exponential form. Exponents. Okay, now what is the, where it is exactly used exponents? So it is a very wide applications. We are going to express the large amount of data. So large amount of data or very small amount of data we can represent easily in the form of exponents. In the form of exponents. Now how to represent the large amount of data in the form of exponents? Let me consider now. Let me see. Now distance between sun, the diameter of the sun, we can see diameter of the sun. Diameter of sun. So it is a large amount. Diameter of sun. How much diameter of sun we can see? This is 140 crores meters. 140 crores meters. This is, so 3 digits, next 2 digits, next 2 digits, next 2 digits. This is 140 crores of meters. So how do you like to express this one? So how many zeros are there here? 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros are there. That means we can simply dash 14 into 10 to the power of 8 meters. 10 to the power of 8 meter. That means, so if 10 is repeatedly multiplied 8 times, then 8 zeros will come. If 10 is multiplied repeatedly 8 times, that is 8 zeros will come. That means 14 into 10 to the power of 8 meters. So like that, so such a large amount of information will be converted into small amount of, very small amount of information by using the exponential form. Exponential form. So this is very useful. Now, what is the mass of the sun? Mass of the sun. Mass of the sun. So one can imagine what is the mass of the sun. So this is 19899100000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. This is about mass of the sun. This is about mass of the sun. So this mass of the sun can be represented. So how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26, that is 19, 8, 9, 1 into 10 to the power of 26 kilograms. So see, such a big number is simply converted into very small form, very short form. This is the application of a standard. This is the application of exponents and powers. Exponents and powers. Now we can see what are the laws of exponents. Laws of exponents. So laws of exponents, we can see now. Laws of exponents. Laws of exponents. So we know that if two numbers with the same base having the different powers, let me take a power m into a power n. This is first law. A power m into a power n. So a power m into a power n. That means here two exponential forms are in product condition having the same base a. So can be represented is a power m plus n. A power m plus n. If two exponential forms are under multiplied condition having the same base, then their powers should be added with the same base. Powers should be added with the same base. This is also very, very important formula. So if two numbers are in the exponential form, those two numbers having the same base, then so that powers should be added, that is a power m plus n. Next, coming to second formula, if the same values a power m by a power n, if exponentials are under division condition, then the exponents will be difference. So we can get difference of their exponents and the power. So in this case, m is greater than n. M is greater than n. So in the same formula, we are going to consider 1 by n minus m. 1 by m. This can be written as here m is less than n condition, where m is less than n condition. So this is called exponential formulas. Now coming to third formula, I can see third formula, that is laws of exponents. A power m whole to the power of n. If a is m times, then whole will be n times. So what is the meaning of this statement? A power m means a is m times, it is repeatedly multiplied, a is m times, then whole is again n times. That means it will become a to the power of mn, a to the power of mn, a to the power of mn. That means powers will become products. So exponential powers forms will become product in this case. Next, coming to fourth one. If you have two different powers with the two different exponents with same powers, a power m into b power m, we are making the exponent as same, that is common exponent. We are going to write this numbers as common exponent, that is ab whole to the power of m. A power m into b power m can be written as ab whole to the power of m. So in this way, in the same way, a power m by b power m can be written as a by b whole to the power of m, making common power, making into common power. These two formulas comes under making common powers. Okay, this formula comes under power whole power. Power whole power will becomes product of the exponents. So these two formulas, product condition and division condition. Under product condition with having same base is nothing but powers are added. Under division conditions with having same base is powers are subtracted. So this is m greater than n case a power m minus n, and n less than n case 1 by a to the power of n minus m. So this is called loss of exponents. Loss of exponents. So now, so we have to observe that for powers with a positive power, negative power and zero power. If you have positive power, a power 2, a power 2, what it means that a power 2? A power 2 means a is repeatedly multiplied 2 times, that is a into a into a. So if you consider a power 0 means, a power 0 means what? 1. This is a power 0 means 1, because a power 0 means a is multiplied 0 times. A is multiplied 0 times means a is not there. If a is not there under product condition, why? Because the exponent is product. Exponent is nothing but product. We know that exponent is nothing but, so a power 2 exponential form, that is a into a. Under product condition, no value is there means it will be exist multiplicative identity. Then under multiply condition, no value is there means it is there in identity. Okay, that's the reason why we are taken a power 0 is equals to 1. A power 0 equals to 1. So coming to the negative power, a power minus 1. If a power minus 1 having the negative powers, so when having the negative powers, then the value comes under denominator, that is 1 by a, that is 1 by a power 1. So you can take a power minus 2, this is 1 by a square. Under denominator it will becomes, under denominator it becomes a power minus 2. Negative powers in the sense we are going to take, that is denominator. That is a power minus m can be written as 1 by a to the power of m. This is another formula. We have to take loss of exponents 6. That is a power minus m is equals to 1 by a to the power of m. This is called loss of exponents. Then, so I hope you understand now. So if you have any fractional powers, what it happens? Fractional powers, it becomes roots. Fractional powers. Actually, this is not there, but we have to observe what the fractional powers exist. When a fractional power is exist, what happens? Suppose fractional power. Fractional powers. So you can see a to the power of 1 by 2. What it happens? A to the power of 1 by 2. When it is a fractional power, it becomes square root of a. Square root of a. So a to the power of 1 by 3, fractional power. This is cube root of a. So a to the power of 1 by n can be written as nth root a, nth root a, nth root a. This is called fractional powers. We see fractional powers and positive powers, negative powers and zero power also. Zero power also. So these are called exponents of, so loss of exponents. Loss of exponents. One should keep this loss of exponents in your mind. So definitely we can solve any type of problem by using exponents and powers. Exponents and powers. So now we are going to see some examples how to solve the exponents and powers. Now you can see, simplify and give the reasons. From the first question you can see minus 2 whole to the power of 7. What it means that minus 2 whole to the power of 7. So we know that minus 2 is the base and 7 is the exponent. Minus 2 is the base and 7 is the exponent. When minus 2 is repeatedly multiplied 7 times, then minus 2 into 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 minus 2. How many times? 1, 2, 3, 4, 5, 6. And 7 times. If negative symbol is repeatedly multiplied 7 times, then it becomes odd number of times. So then can be written as minus into 2 to the power of 7. That is, so 2 how many times? 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are so 32, 32 2s are 64, 62 2s are 128. So this can be written as minus 128, minus 128. So another form we can write this as, so minus 2 power 7 can be written as minus 1 power 7 into 2 power 7. So minus 1 power 7 becomes minus, this is 128. Like this also we can represent minus 1 power 7. That means we have to remember one formula here. Minus 1 power odd exponent will becomes minus 1, minus 1 power even exponent will becomes plus 1. So this is also very important formula. Minus 1 power odd exponent, that means odd number of times we are going to repeat the minus 1, then it becomes minus 1. Even number of times we should repeat the minus 1 value, it becomes positive value, that is plus 1. So now, so this is about the question minus 2 power 7 value. So now 3 by 4 whole to the power of minus 3. How to simplify this one? So as we know that, so formula, the reason formula, a power minus m can be written as 1 by a to the power of m, 1 by a to the power of m. So this can be written as 1 by 3 by 4 whole to the power of minus 3 can be written as 1 by 3 by 4 whole to the power of 3. So this can be written as 1 by, so this is again the formula a by b whole to the power of m can be written as a power m by b power m. So this can be written as 3 power 3 by 4 power 3. So now it should be 1 by, under denominator again it is division, it becomes reverse, 4 power 3 by 3 power 3. So 4 power 3 means 4 into 4 into 4. 3 power 3 means 3 into 3 into 3. So 4 4 16, 16 4s are 64. Then 3 3s are 9, 9 3s are 27. The answer is 64 by 27. 64 by 27. Next comes to the question. So third comes to the question 3. So what is this value? So coming to question number 3, minus 3 whole to the power of minus 4. That means what? So this can be written as 1 by minus 3 whole to the power of 4. Minus 3 whole to the power of 4. So this can be written as 1 by minus 3 is multiplied by 4 times. So we know that minus is repeatedly multiplied even number of times. It is plus. This is plus 81. 3 3s are 9, 9 3s are 27, 27 3s are 81. The answer is 1 by 81. 1 by 81. This is called how to simplify the given values. Simplify the given values. So next we are going to see some more examples how to solve these questions. Some more examples. Now we have to solve this question. 1 by 2 whole to the power of 4 into 1 by 2 whole to the power of 5 into 1 by 2 whole to the power of minus 6. Let me observe this one. It has all the bases are equal, same base. So we know that formula, if any exponents having the same base under product condition, it becomes a power m plus n. So here only two terms. Third term is also there. So we add third term also, no problem. That is a power l. That can be written as a power m plus n plus l. Like that we can consider. So if you add, that means here also we can take 1 by 2. 1 by 2 as a base. Then powers will be added 4 plus 5 minus 6. Actually plus 6, but here minus 6 will be there. That's why minus 6. That is 1 by 2 whole to the power of 4 plus 5, 11 minus 6. That is 1 by 2 whole to the power of 5. So this can be written as 1 power 5 by 2 power 5. So under a by b whole to the power of m condition. Then 1 power 5 means 1, 2 power 5 means 32. Answer is 1 by 32. Like that we can do this problem very simple way. Okay. So now again, so how to solve the remaining questions you can see now. So I'm going to use how to find x value if it is missing x. Then we stop this chapter. How to find the value of n if 7 power n plus 1 divided by 49 is equals to 7 power 3. So you have to write this is 7 power 2n plus 1 divided by 49, that is equals to 7 power 3. This is given. So as we know, 49 can be expressed as 7 square, that is 7 power 2. So you have to take 49 here, 49 in 7 tables, 7 sevens 49, again 7 ones. This 49 can be written as 7 square. This is called prime factorization. So prime factorization, if any number want to convert into exponential form, you can do the prime factorization, how the factors will become. Then repeated factors were taken as exponents. Repeated factors were taken as exponents. Now here 7 is repeatedly multiplied, so 2 times, then we get 49. This can be written as 7 power 2n plus 1 divided by 7 power 2, that is equals to 7 cube. So under this formula, this is in division condition. So a power m by a power n is equals to a power m minus n formula. So this can be written as 7 power 2n plus 1 minus 2, that is equals to 7 power 3. Now this is 7 power 2n plus 1 minus 2 minus 1, that is 7 power 3. So now it is a power m is equals to, you can take a power n. So if two exponents having same base and under equal conditions, so definitely exponents also should be equal. Exponents also should be equal. That is 2n minus 1 is equals to 3. Then 2n is equals to 3 plus 1. So 2n is equals to 4, or n is equals to 4 by 2, that is equals to 2. Therefore n is equals to 2. Like this we have to find exponents values. Exponents values. If a variable is takes place in the exponents condition, you have to find how to find the exponential value like this. This is equals to n. So I hope students you are clear in the concept of exponents. If you have any doubts, while writing exponential forms, okay, you can ask me later. Thank you.